Okay, so we can get started. This is chapter 1, section 4b, solving quadratic equations by completing the square. Now, on your quiz, I'll give you guys this information. It'll be 10 questions, right? Of those 10 questions, 9 are going to say solve, and 1 is going to specifically say to complete the square. All right, so 10 questions total, and this is going to cover all of the material from 1.2 AB. So that was solving linear equations and solving the rational equations, and then it's going to cover 1.4A, which we did yesterday, and B, which we're doing today. All right, so lots of different equations. I'm sure as I'm going through these examples, you guys maybe understand how to do it. The difficult thing is going to be when you get just 9 problems and they all just say solve. Right? I won't tell you how to solve it or what lesson it's coming from. You'll just have to know which method to use given a certain problem. All right, so again, 10 questions, 9 say solve, 1 says complete the square. All right, now there's a lot of words on this page. All right, don't stress yourself with these words. I think it's easier to just show you guys how to do it. So let's just start with one of these. I will say on your quiz, I know this is a little bit harder of a lesson. Maybe not harder, but it requires definitely more work than some of the other ones. So for the sake of your quiz, it's going to look like something on this page, right? I think something on this page would be a little bit easier to do than some of the later problems. We'll save maybe something like that for your test, right? But for the sake of your quiz, the one completing the square one that you get might look like something on this page. Now, when we're completing the square, the first thing I want is I want to make sure A is equal to 1. Right? I maybe skip over that for these next few examples because a lot of these A is 1. In other words, I don't want anything in front of the x squared. So in this first one, is the x squared by itself already? There's nothing in front of it. Yeah, right? So I can check that off, right? The next thing I want to do is I want to move my c term. So move the constant term. My constant term here is going to be this negative 14. I'm going to add it to both sides. So I get an x squared minus 4x. And I'm going to add a little blank. 14, sorry. And then 0 plus 14 is going to be 14. I'm going to add another little blank. You'll see what we're going to put there in a second. Right, so the goal, I didn't even explain that first part, but the goal here is to get it to look like something that we did yesterday, right? Something that we did yesterday, I had like a parentheses squared equals a number. And then how did we solve something that looked like that? Square root, right? Just square root. And then I get whatever's inside plus minus whatever this is. That's the goal here, right? We already know how to do that part. The goal is just to get it to look like this so that we can do that. All right, so the goal now in our next step is to make a perfect square trinomial. I'm going to add b over 2 squared to both sides. Now b is that middle term in front of the x, right? So it's going to be this negative 4. So I'm going to add negative 4 over 2 squared. All right, what do I get when I do negative 4 over 2 squared? Okay, 4, right? So I get negative 2 squared, which is 4. So I'm going to add 4 in this little space. So maybe we don't see y yet, but look at what's on this side of the equation. Does that factor any special way? Can we do anything to this? X squared minus 4x plus 4? What does that become? It's a perfect square trinomial, right? And that's going to work out every single time when you're completing the square. This left side of the equation is always going to become a perfect square trinomial, right? We see that factors of 4 that add to negative 4, negative 2, negative 2. It's always going to be the same thing. And it's always going to be whatever you did when you did b over 2. So if b over 2 is negative 2, it's going to be x minus 2 squared. So this became this. Are you okay with that part? All right, so I factored the left-hand side as a perfect square trinomial. And then what does the other side become? 18, right? 14 plus 4. 18. All right, and then I'm going to square root both sides. Now, does this look like something we did yesterday? Right, very similar, right? So all I have to do is square root both sides. And then so the square root and the square are going to cancel out. And then I get an x minus 2 equals what? Good, right? Glad that you said plus minus. A lot of people forget it. Plus minus the square root of 18. When you're taking the square root of x squared, or anything squared, any variable squared, it's going to be a plus minus. You need to account for both solutions. All right, so there's a couple ways we can go about it now. We can start by getting the x by itself. All right, so to get the x by itself, very simply, I'm just going to add the 2 to both sides. So I'm going to add 2, and then I get x equals 2 plus minus the square root of 18. Can I do anything more to that? Weapon? Okay, nothing more to this, right? This is going to stay fully simplified. Can I do anything to the square root of 18? Does that become anything else? Yeah. Weapon? Okay, good, right? Do you see that square root of 18 is the square root of 9 square root of 2? All right, so I can simplify it a little bit more, and the square root of 9 is 3. So I get x equals 2 plus minus 3 square root of 2. And then that would be my fully simplified final answer. So maybe the first time you're seeing this, I think maybe some of you did it in Algebra 1. Maybe you did and you don't remember it, right? So maybe right now it's like, oh gosh, there's a lot of steps in each problem. But the more you do it, you're going to realize it's the same steps every single time. So if you can go through the motions of doing a problem like this multiple times, you're not going to forget it, all right? Any questions so far on this one? So far, so good? Okay. So I'm going to leave that up. We'll try number 2 now. So again, the first thing I want to do, check that a is equal to 1. Is it in this case? Is there anything in front of our x squared? No, right? So I can skip that step. All right, what was the next thing that we did? You're looking at our previous problem, right? What did we do next?
Move the C.
Okay, good, right? So I'm going to move that c term, and that's going to become, I can add a 1 on both sides. So then I get, x squared plus 6x. I'm going to add my little space, equals 1, and I'm going to add my little space. And what goes in that little space? Do you remember?
B divided by 2 squared.
Okay, good. B over 2 squared. So it's going to be 6, right? 6 is our B term. Over 2 squared. All right, what does that give us? 9, right? 6 over 2 is 3. And then 3 squared is 9. So I'm going to add 9 in that little space. And then doing that is going to make this side a perfect square trinomial, right? How is this going to factor? Okay, good. X plus 3 squared. I'm glad that you said it that way and not x plus 3 and x plus 3, right? That's not wrong if you said x plus 3, x plus 3. But for the sake of this problem, we want to solve it by square rooting. So I want to write it as x plus 3 squared. Equals, and what's on the other side? Okay, good. So right now it's 10. And then our next step is we're going to square root, right? So I'm going to square root both sides, and then that leaves us with the square root of 10. Good. So then the x squared and the squared cancel. And then I'm left with x plus 3 equals... Okay, good, right? I was about to ask. Not just square root of 10, right? Plus minus. Very good, guys. And then what's the last thing we have to do to get our x by itself? Very good, guys. Subtract the 3. And then I get x equals negative 3 plus minus the square root of 10. Can I simplify square root of 10 at all? Can I just leave it? Just leave it, guys. Right? 10 doesn't have any factors that are perfect squares. It's also not a perfect square, so I would leave it alone. How is it the second time around? Better? Hopefully a little bit better, right? So as you do more of these, they get a little bit simpler. I don't know if it's too soon, but I want you guys to try the next one on your own. All right, I'll see how we do, and then I'll do it together. All right, so give it a try, see what you get. Okay, good, so most of us got it. Good, so again, very first thing, add the 5 to both sides. And then I get an x squared plus 2x plus a little space equals 5 plus a little space. And then in that space, looks like most of us got it, is going to be b over 2 squared. So it's going to be 2 over 2 to the second power. So 1 squared, which is 1. And then I'm going to add the 1 on both sides. And now this on the left is going to be a perfect square trinomial. That's going to become x plus 1, x plus 1. So x plus 1 squared, and on the other side I'm going to have a 6. And now this looks like something we did yesterday, so I can square root both sides. I get an x plus 1 equals plus minus the square root of 6. And then we could subtract 1 to both sides, and I get x equals negative 1 plus minus the square root of 6. All right, so it looks like a lot of us got that. Nice work, guys. Another thing that I saw, it's okay if you write it as plus minus the square root of 6 minus 1. I don't really care. Just sometimes when you're looking at your work, I like the radical at the end just because maybe you're working too fast, you get confused, you kind of extend that radical a little bit, and then you stop thinking for a minute and you do 6 minus 1. And then you get the square root of 5. All right, so just careful with that, but it's fine if you do it. It's fine if you do it and you just leave it like that, right? That's fine. All right, so let's try the next one. So again, on your quiz, might look something like the first page, but let's try a little bit harder ones just to prepare you in the future for your test. Maybe you see something like it. Let's try something like this. So again, move the c to the other side. So I'm going to subtract 12. And so I get x squared plus 7x plus a blank equals negative 12. All right, and what should go in that blank? Good, right? In this time, it gets a little bit harder because this doesn't get us a nice whole number, right? If I do 7 over 2, right, that's just going to stay a fraction. There's nothing more I can do to that. But I can still square it and do the same process as always. Right, do you remember how to square 7 over 2? Seven over 2 times 7 over 2. Yeah, good. Thanks. All right, 49 over 4. Another thing you could do, square the top, square the bottom. Doesn't matter how you do it. You're probably going to want to take the mental shortcut and do square the top, square the bottom in the future, right? The next few examples are going to have a lot of fractions, right? So 49 over 4 is what's going to go in that little space. Can we see that? It's a little small. I'll try to make it a little bigger. Okay, so then that is going to factor as a perfect square trinomial. But you don't want to waste your time trying to find factors of 49 over 4 that are going to add to 7. All right, that's going to take a long time. It's always going to be this middle b over 2 number. All right, so 7 over 2, that's always going to be your perfect square trinomial. It's going to be x plus 7 over 2 to the second power. Hi. And then on the other side, what does this become? Negative 12 plus 49 over 4. Good, right? So we remember how to add a fraction and a whole number. This is going to be negative 12 over 1. And we need a common denominator. Negative 12 times 4 is going to get you a negative 48 over 4 plus 49 over 4. 48 plus 49, I'm sorry, negative 48 plus 49 is going to get you 1 over 4. All right, so the steps aren't harder, right? They're just seem harder because it's a fraction and not a whole number, right? But it's still the same steps every time. Hopefully the process is getting a little bit simpler now. And now that I have something squared on one side, a number on the other, what can I do to both sides? Square root, good. So then I get x plus 7 over 2 equals, what does that side become? Okay, plus or minus what? Okay, what? You said what on the bottom? Okay, so we can square root the top, square root the bottom, just like with exponents. Square root of 1 is 1. Square root of 2 is 2. So I just get 1 over 2. All right? All right, one more thing I have to do. Subtract 7 over 2 on both sides. So then I get x equals, I'm running out of room. Let me write it down here. X equals negative 7 over 2 plus or minus 1/2. I know yesterday was quick, but I think there was one example. Do we remember if we can do anything more after this? Yeah, right, so you can split it up into two different answers, right? So this is going to be negative 7 over 2 plus 1/2 and negative 7 over 2 minus 1/2, right? I'm doing it this time and not the other ones just because if you look at the previous page, we only had radicals in our answer and there's nothing that we can do when we split it up to simplify it a little more. I can simplify adding fractions and subtracting. So I get negative 7 over 2 plus 1 over 2. So negative 6 over 2, which is negative 3, as one of my answers. And I get negative 7 over 2 minus 1 over 2, which is negative 8 over 2. So negative 4. All right, running out of room, but we get negative 3, negative 4. So we get whole numbers this time, integers. Can we see that back there? Good. Okay. So the fact that we got whole numbers tells us something about the original problem, right? Did I have to solve this by completing the square? Probably not, right? If I'm asking that question. But what's another way that you could do? So let's look at this original problem. Is there another way that we can solve it that we can maybe finish it in like 20 seconds? Sorry. Did you think the same thing? Okay, yeah, good, right? So you can factor it, right? So factors of 12, that adds to 7 is going to be 3 and 4. So we get x plus 3, x plus 4. That's what we learned yesterday. Solve it by factoring. And then set each factor equal to 0. X plus 3 equals 0. X plus 4 equals 0. Subtract the 3 on both sides. I get x is negative 3. And I get x equals negative 4. So we get the exact same answer in a fraction of the time. All right? If on the quiz it just says solve, solve it however you want. And honestly, you should check if you can factor it first. You don't want to spend all of that time completing the square if it's factorable, right? And this took like less than a minute to do. All right, so that's something to check, right? Check if you can factor it first. I will say like maybe 90% of the examples in this set of notes don't factor for that reason. Just because if it doesn't factor, this is going to be the next thing that you do. Either completing the square or quadratic formula, which if you guys remember from Algebra 1, can't use it yet because you haven't, I guess, learned it in this class yet. All right, are we okay with this example? So a lot of work to get negative 3 and negative 4, but still the same process. All right, let's try the same thing with the next one. All right, so what can I do here first?
We have to
Okay, good. Again, same steps every time. I'm going to add 6 to both sides. I get x squared minus 3x plus a blank equals 6 plus a blank. And what goes in that blank? Ideas? You know it? I see you. Okay, yeah. B over 2 squared. I saw you looking. It looked like you knew it. So negative 3 over 2 squared. B over 2 squared. And then squaring this, right? Square the top, square the bottom. This is going to get you 9 over 4. And that's what I'm adding to both sides. All right, and when we do that, how does this factor now on the left? What is that going to become? So we know it becomes a perfect square trinomial. So it's going to be x and what squared? Good. It's always whatever you did when you did b over 2. So if I did negative 3 over 2 and I couldn't do anything more to that, that's what's going to be in my perfect square trinomial. Don't waste your time trying to find factors of 9 over 4 that add to negative 3. All right? And then on the other side, I can do what I did in the previous problem. Write the over 1 and find a common denominator. And then 6 times 4 is going to get me 24. If I do 24 plus 9, that gets me 33 over 4. All right, what can I do now to both sides? Good, square root. And so I get x minus 3 over 2 equals plus minus the square root of 33 over the square root of 4 is going to get you 2. So you can square root the top, square root the bottom. Don't forget the plus minus. So far, so good? The very last thing we want to do is I want to add the 3 over 2 to both sides. And then so I'm going to write it up here. I'm going to get x equals 3 over 2 plus minus the square root of 33 over 2. And then that's your final answer. Nothing more we can do to that.
How do we get the 3 over 2 to 9 over 4?
So when completing the square, it's going to be this little term, this middle one, always divided by 2 squared, and that's what's going to go in both of these. So square the top, square the bottom. Another way that you could write your answer, since they both have a denominator of 2, it could be 3 plus minus the square root of 33 over 2. Right? That's also fine to write it like that. All right, how much time do we have? Okay, I'll try to get through 1 or 2 more examples. I want you guys to have time to start your homework. So let me try to do, I'll do this one. Okay, number 6. What's different about number 6 and the other ones? Okay, good, right? So do we see that the first term is not equal to 1? So there is a way to factor by completing the square while keeping the a there. And then we'll probably do that in a couple weeks when we get to graphing quadratic functions. But for the sake of just solving, I just want to know what the answers are. I'm just going to divide every single one of these terms by 9 to make x equal to 1. So let's divide every single thing by 9. And then doing that, the 9 and the 9 are going to cancel. And then I get x squared minus 12 over 9. What does that become? 4 over 3. X. And then can't do anything more to 1 over 9, so I leave it alone. Equals 0 divided by 9 is just 0. And so we get this kind of as our new equation. And then now when it looks like this, I can solve it by completing the square exactly the same way as we've been doing. The steps aren't harder. They didn't get harder. It's just now you have a fraction. instead of a whole number in the middle. All right? So as always, I can get my c turned to the other side, so I can add 1 over 9. And so I get x squared minus, let me try to make that bigger. Yeah, x squared minus 4/3 x plus a blank is going to equal 1 over 9 plus a blank. And now this time it's a little different with the b over 2 squared. Because when I do negative 4 over 3 over 2, how am I going to simplify that? Either how do I simplify it like this, or what's another way I could write it? No idea. Okay, yeah, good. So you can write it as 2 over 1, right? And then we see that we can keep change flip. So that's going to become negative 4 over 3 times the reciprocal of 2 over 1 is 1 over 2. Or you could have started here. You could have started with the 1/2, and you can recognize that dividing by 2 is the exact same thing as multiplying by a half. So then this is what's going to be my b over 2, right? This is going to be my b over 2, and I want to square it. And then, of course, you can simplify it a little more. The 4 and the 2 are going to cancel out, and that's going to become a negative 2 over 3 squared. And then when I do negative 2 over 3 squared, that's 4 over 9. Square the top, square the bottom. I'm kind of running out of room, so I'm going to try to squeeze it in at the bottom. All right, so then this right here is going to become a perfect square trinomial. It's going to factor the same way as it did before. It's going to be x plus b over 2, all to the second power. And in this case, b over 2 was this negative 2/3. All right, so x minus 2/3 squared. And then equals, over here, 1 over 9 plus 4 over 9 is going to get you 5 over 9. And then just like before, I can square root both sides. And so I get x minus 2/3 equals, I can square root the top, square root the bottom, plus minus square root of 5 over 3. And then very last thing I want to do is add the 2/3 to both sides. And so I get x equals 2 over 3 plus minus the square root of 5 over 3, which that's an acceptable answer. Or you can write it under a single fraction. I don't really care. 2 plus minus 5, square root of 5 over 3, like that. That's fine as well. Yeah, so when this, okay. So the same thing as, 2, so 2 is the same as 2 over 1. Let me actually write it over here. So if I had negative 4 over 3 over 2, all right, just looking at that, we don't really know what to do with it. But I think last week or the week before when we learned complex fractions, we know that we can keep change flip. So to get it to be something that we can keep change flip, I want to make the bottom a fraction. So I made it a 2 over 1, right? Anything over 1 is itself. And now it looks like I can keep the, keep the first. Keep that. Whoa, I don't know why it keeps doing that. Change that division to multiplication, and then flip that last fraction. So times, and then 1 over 2. Is that a little better? Okay, nice. All right, so we got some time left. I'll do one more. And then the other 3 examples on the next page, I'll record outside of this class, so that way you guys have it. And then I'll have that out by today. So a lot of work on the page right now. Let me try to squeeze it in. So let me actually erase that. We got the answer to that already. All right, so same exact thing with this one. What's the first thing we do here? Good, divide by 3. All right, when you divide by 3, the 3 goes away in front, and then I get an x squared plus 2/3 x minus 5/3 equals 0 divided by 3 is 0. All right, what's the next thing we do? Good, right? I want to add the 5/3. So then I get x squared plus 2/3 x plus a little blank equals 5/3 plus a little blank. What should go in that blank? Okay, so it's going to be b over 2 squared. So doing that in this case, it's going to be 2/3. You can either divide by 2 and then keep change flip like before, or you can multiply by a half. They mean the same thing. And then doing that, the 2 and the 2 are going to cancel out, and I get 1/3. And then here I can square 1/3. So I'm putting b over 2 squared in each little space. So 1/9. And then this is going to factor as a perfect square trinomial. Again, don't try to find factors of 1/9 that add to 2/3. It's always going to be 1/3, right? So it's going to be x plus 1/3 squared equals, and then 5/3 plus 1/9. How can I add those? All right, how can I do 5/3 plus 1/9? Nice, guys, right? Times 3 on the top and on the bottom to get a common denominator. 2/3 times a half, the 2's are going to cancel. Or you can multiply straight across and get 2/6, and then simplify to get 1/3. Well, you would divide by 2, but dividing by 2 is the same as multiplying by a half. So if I did 2, it's kind of like what I did in the previous one. If I divide by 2 like that, I get a fraction over a whole number, which doesn't look nice, so I want to make it into something that we can keep change flip. What happened? That's always the process, right? And every single one of these we would divide b over 2. All right. Okay, nice, guys, good, okay. So then simplifying this now, 5 times 3 over 3 times 3. All right, we get a 9 on the bottom and a 15 on top. And then I get a 15 plus 1 on the top, which is going to get me a 16 over 9. All right, so kind of did a lot in that one step, right? 5 times 3, 15, plus the 1 over the 9. All is a common denominator of 9. Okay, and then after this, what's the last thing we do? Okay, good. Square root. And then I get x plus 1/3 equals what? Plus or minus 4/3. 16 over 9 is a perfect square. You can square root the top, square root the bottom. Okay, and then now what's the actual last thing that we do? Good, right? Subtract the 1/3. And then I'll write this up here. So then I get x equals negative 1/3 plus or minus 4/3. Can I do anything more to that? All right, good, right? Split it up, right? So I get negative 1 over 3, good, plus 4 over 3. And then I get negative 1 over 3 minus 5 over 3. And then I'll write it over here. This is going to become 3 over 3, which is 1. And this over here is going to become, I skipped a step, right? That should be 4. Equals negative 5 over 3, which doesn't simplify. So we actually get these as our two answers. Again, what does that tell us about the original problem? What could we have done to it? What could we have done to solve it a little bit faster than the way we did it now? Good, right? We could have factored it. Do we see that? We could have done 3 times -5 and got -15, and then factors of -15 that added to 2, which would have got us a 5 and a -3. Slide and divide, do all that. Set each factor equal to 0. So again, unless specified, right? Unless the quiz, I say, solve by completing the square, solve it however you want, you should check if you can factor it first, because that's going to be the quickest way that you can solve it. All right, I'll finish the other 3 examples outside of class that you guys have it. All right, you should see the video today. All right, so I'm going to finish the last 3 examples that we didn't finish in class, but it's all the same process, right? So the first thing in this one, you'll notice in this page, all of them have a not equal to 1. So the first thing I want to do, get rid of that 3 in front. Divide everything by 3. And then it's going to cancel out over here, and then I'm left with an x squared minus 4/3 x minus 1/3 equals 0. All right, and then from here the process repeats. I'm just going to add the 1/3 to both sides. All right, so always add c to the other side. And then I get x squared minus 4/3 x plus, I'm going to add my little blank. And then equals 1/3 plus the blank. All right, and then I do b over 2 squared, so it's going to be -4/3 over 2. Now, like I mentioned in class, you can either divide by 2 and then keep change flip, or you can multiply by a half. All right, cancel out the 4 and the 2, it's going to be a 2 over 1. So I get a -2/3 as my b over 2. Square it, and that's what we'll put in that little blank. So I have a 4 over 9. All right, and then this is going to become a perfect square trinomial. Again, don't try to find factors of 4 over 9 that add to -4/3. It's always going to be b over 2. So it's going to be x minus 2/3 squared equals, and then we can combine these two, find a common denominator, so multiply the top and the bottom by 3. So I get 1/3 over 9, 3 over 9, and then I add the 3 and the 4 to get a 7 over 9. And then from here, it looks like something that we did yesterday, so not divide. Square root the left and the right. Square root and the square cancel. I get an x minus 2/3 equals plus minus square root the top, square root the bottom. I get a square root of 7 over 3. And then lastly, I can add 2/3 on both sides. And then I get x equals 2/3 plus minus the square root of 7 over 3. Nothing more we can do to that to simplify it, so I would leave it alone. Again, if you want to write it under a single fraction, you can do 2 plus minus the square root of 7 over 3. That's fine as well. All right. One more like that. Again, first thing we want to do, divide that 5. Make sure a is equal to 1. So divide everything by 5, and then I get x squared minus 7 over 5x minus 1/5 equals 0. And then we start our process, right? Add the 1/5 on both sides. Let me write it over here. It's going to get me an x squared minus 7 over 5x plus the blank equals 1/5 plus the blank. And then we complete the square, right? Find b over 2 squared, so -7 over 5 times a half. All right, that doesn't simplify at all, so this is going to stay -7 over 10. And then I square that, that's going to get me 49 over 100. All right, so put that in that blank. So 49 over 100. All right, and then this side is going to become a perfect square trinomial. Again, it's always going to be x plus b over 2 squared. So it's going to be x minus 7 over 10, all right, squared. And then on the other side, I want to find a common denominator between 5 and 100. It's going to be 100, so we can multiply the top and the bottom by 20. And so I get 20 plus 49 on top is going to get us 69. Over on the bottom, I get 100. And then I can square root both sides. and then I get x minus 7 over 10 equals plus minus the square root of 69 over 10, right? Square root of 100 is 10. Very last thing I have to do is add 7 over 10 to both sides. And then I get x equals 7 over 10 plus minus the square root of 69 over 10. Again, you can choose to write it under a single fraction. One's not better than the other, they're equally correct. Just one is separated, one isn't. So it can either write it like this or like that is fine. All right, one more and it's a little bit simpler. All right, so this one looks a little bit easier than some of the other ones. Just keep in mind there is a negative in front of that x squared. So I want to divide everything by that -1. Alternatively, you can move everything to the other side to change the signs. Doesn't matter how you do it, as long as the signs all change. So I get something like that, right? Dividing that -1, now a is equal to 1, all right? And then the process repeats, right? Add the 5 on both sides. I get x squared minus 3x plus the blank equals 5 plus the blank. And then I do b over 2 squared, right? No fractions in this case, so it's just going to be -3 over 2 squared, so 9 over 4. And that's what's going to go in the blank. And then this is going to factor as a perfect square trinomial. It's going to be x minus 3 over 2 squared. Again, always use b over 2. Equals, and then 5 plus 9 over 4, I'm going to find a common denominator. I'm going to write the over 1, multiply the top and the bottom by 4. And then 5 times 4 is going to get me 20. And 20 plus 9 is going to get me 29 over 4. Very last thing, I'm going to square root both sides. Get x minus 3 over 2 equals plus minus the square root of 29 over 2, right? Square root the top, square root the bottom. And then I lied. Actually, the very last thing we're going to do is add the 3 over 2 to both sides. And so I get x equals 3 over 2 plus minus the square root of 29 over 2. And that would be the final answer. Again, said it 100 times by now. At this point, we can also write it under a single fraction. So it's going to be 3 plus minus the square root of 29 over 2. It means the exact same thing. All right, so these problems don't get harder, right? The steps itself doesn't get harder. The only thing that makes it harder is sometimes you get a fraction in some of them, but the steps should be exactly the same. Sometimes it takes a lot of work. Again, on the quiz, just read the directions. If it just says solve, check if you can factor it. If it says solve by completing the square, you have to do it this way.